Hello, everybody. This is Professor Jason Kim. Today, we're going to talk about the chapter one, statistics. What is statistics? Statistics is a science of the learning from data. It is the scientific study of how to collect and analyze and interpret and present the data objectively in the presence of uncertainties. So that's the definition from the world of statistics. According to our Wikipedia, statistics is a study of a collection, analysis, interpretation, and presentation, organization of data. So both of them are saying something about doing something from the data or of the data. And some other textbooks definition is statistic is study of how to collect, organize, analyze, interpret numerical information from the data. So all of them in definition of statistic, they're talking about gathering the data, process the data, and make useful information. So I guess that's the general definition of statistics. So here is the data, and you process them and make a useful information. From the raw data you have to process. There are many different types of processing. So as they say, they collect and analyzed, organized, and interpret, and many other processes. So when we have a raw data that you collect by doing several different process, you try to make a useful information. And statistic is like doing this kind of thing so we can use out of the data as a useful information. So then how do you collect the raw data? So in gathering the data, but you have to know what kind of data is out there. The data, we generalize into data into two different topics. One you can write in a number, one you can gather as other than number. So when the data is numerical type or number type, we call quantitative variable or quantitative number or quantitative data, like age, how old are you, how old you are actually. So let's say in my case, if I'm 25, so number 25 is the data. But the 25 is what kind of type of this data? It's a quantitative data. My height, my income, my social security number, my date of birth, my credit card number, all those are the quantitative variable or quantitative data. Compared to that, there is another type of data called qualitative variable or qualitative data. It's like many cases like categorize of the group, like either you are male or female, gender or nationality, or yes or no, color of your eye, color of your hair, many other things. So it's not represented as a number. Usually that kind of data as qualitative variable or qualitative data. So that's the separating or distinguishing the type as a type of data. Is it number or is it not a number? Also, when you gather the data by the source of data, one we call population data, and the other one we call sample data. So population data is usually the data from every individual, and sample data is data from some of the individual. That's the difference. So population data is all the data, in other words. And sample data is a part of the data. Okay. So based on the source of data, we can also divide the data into population data and sample data. So it's a method. It's matter of how you interpret the data, which way. Is it type of the data or is it source of data? Okay. And when you that's the raw data. Now, processing the data. So gathering the data is like this. Now, what kind of process we are talking about? Okay. The process means you measure the like average, getting an average, using probabilities, sorting. So that's like processing the data, or inference data, something called inference data that you interpret in different way. Okay, so that's the processing of data. Now, when you have in statistics, we use a lot of symbols. In general, Greek letter, the letter from Greek letter used to measure a population data or population parameters, and the Latin letter, the letter that we used to use in time period, they use the Latin. So Latin letter is to measure for more of a sample data, we call statistics, compared to population data as a parameters. Okay. Now, why do we need to separate this? The population data and sample data are different. Sample data is a portion of data. You can just make it like 20 data, 200 data, like 2,000 data. Compared to population data is the entire data, like million data, trillion data, like that. So depending on the size of the data, the process might be a little different to be more accurate. As a result, the formula that you use to achieve something might be a little different based on either you are dealing with portion of data, sample data, or entire data, which is population data. So the formula representation in a formula use a little different letter or symbols. Okay. So for example, to represent the size of the data in population parameter or population data, you use the big N, and we use a small n if it's a sample data. So in that way, we know that, we are dealing with the sample data, or we are dealing with the population data, entire data. Okay. And to represent the average, in statistics, we don't call average anymore. We call mean. We use the Greek symbol called like U, but actual name is mu. Like mu. So it's we call it mu. And is average or mean when you use in a sample data, we call X bar. So we call this one as X bar. Okay, so those are the two symbols, two variables that we use to represent the mean value, which is average. One for population and one for sample data. Another thing that you have to memorize is that for the variation, to represent the variation of the population data, we call sigma square, and we use S square for sample data. And to represent standard deviation, we use a symbol for sigma, not sigma square, sigma and S. So those are the three most important symbols that you have to recognize and memorize and distinguish. If you don't memorize this, you might have a very difficult time to pursuing the knowledge of the statistics. So making sure you memorize this symbol and when do we use the symbols and how do you pronounce and how do you use it. Okay. So beside the mean and variable variation and the standard deviation, there is a two different symbols we use represent the proportion. You use a pi for population data and p for sample data to represent the proportion. And correlation coefficient, we use p, or we call rho, and to represent the population, and to represent the sample correlation coefficient, we use r or r. But the most important one is this 3. And whenever I put this star, that means you really have to memorize it. So you might want to copy this in your formula section and memorize it. Okay. And now the data, there are different type of data, different kind of data, what we call level of measurement, or different level of data, levels of the data. There is something called normal measurement, ordinal measurement, interval measurement, and ratio measurement. So depending on the type of data, there are things you can do is a little different. So when you only put into a category, we call normal measurement. And you can not only put in a data into category, you can put into a smallest to largest or worst to the actually the best, or different level, put into different level, we call ordinal. Okay, not only you can just put as a category, but also you can arrange it different way. Then we call ordinal level of data. Interval level of data is you can order and you can also take a difference. So that means you can have like subtraction. Like for instance, rather than that, at the level you make a sense of the comparable two difference between the data value. For instance, you can say that one data value is 5 more than or 12 less than other value. So you can do like subtraction or addition things. That's the interval. Ratio is more likely you can do you can order the data, which means you can do the previous levels, take a difference, which is the interval level, also find the ratio between the data value, which means you can do multiplication and division things. So for instance, it makes sense to say that one data value is twice as large as another one. So things you can do with the data is the level of data. Okay? Again, normal data is put into the category only. Ordinal data is you can rearrange the in order. Interval is you can express in addition and subtraction format, or you can do multiplication and division format because ratio level of the data. And also you can, when you try to change the raw data into useful information, the process that you are doing or type of statistic that you're doing, there are two different levels we can say. One is a descriptive statistic that is involved with the method of organizing, picturing, summarizing information from sample or population data. So most of the concept that we are learning in chapter 2 and chapter 3 and chapter 4 from our textbook or this workbook are something about descriptive statistics. Now, compared to that, there is something called inference statistics. Inference statistics is it involved with the method of using information from sample. And then you draw the conclusion regarding the data. So you have to think harder, not just dealing with a number only. Okay. So most of the lessons or data that dealing with or process that we're doing in chapter 5 through 9 is we call that one as inferential statistics. Okay. So there are many ways of analyzing type of data. Okay. And also there are at least two types of statistics that we are dealing with. One is descriptive and the other one is inferential statistics. And the data, by using these special symbols, data, you can gather the data and you can process the data. Okay. But when you gather the data, there are different types, different source, and measuring the data, inference the data. Okay. Now, another very important concept in this chapter is sampling it, simple random sampling it. The statistics, when you gather the data, when you gather the samples, it's very important that you do randomly, which means you just pick from everywhere without no patterns. Then it's become a fair because you randomly choose it. So it's very important that you choose the random so you can have an equal chance of being selected. That's the whole purpose of this. So you have to do your best to get random samples when you have sample data. And when you do sampling it, there are different type of technique that we use. One is like random sampling, stratified sampling, systematic sampling, cluster sampling, multi-stage sampling, and convenience sampling. Now, as I say before in other videos, that the focus on my lecture, most of the focus of my lecture is based on the what is most important in the topic, and then we're going to go over that the topics, and usually based on your final test, okay? And also what I personally think is important. So in this chapter, there are many things that they talk about it, but the one of the most important one is that statistics is changing or making a raw data into useful information by doing different type of processes. That's important. And to do that, what kind of symbol do we use? That's very important. And recognizing there are two different type of data. One is population data, and the other one is sample data. So those are the most important part of this. Okay, so this is end of the very short preview of chapters. Chapter 1. I will see you in next video or in the classroom. Have a good day. This is the very first chapter 1 preview video. Okay, have a good day and be safe. Bye guys. See you soon.